Hi everyone, my name is Kelly and today I'm going to share with you some of my findings on my quest to detect humor using LSTMs. So humor detection has a lot of interesting applications in text. The most interesting is probably its applications in building AI systems such as chatbots and virtual assistants by being able to identify and inject humor that can make interacting with the systems more engaging, which would overall enhance the user experience. So I was motivated to do this project to see if I could best detect humor in text data myself using natural language processing and deep learning techniques. The dataset I worked with was the Yelp Open Dataset, which contained about 8 million reviews, each of which contained a funny attribute that corresponded to the number of votes a review has received. As you can see, the distribution of funny votes has a very heavy right skew. And so I chose to turn this into a binary classification problem where I redefined funny as being 3 votes or more, which gave me about 340,000 funny reviews total to give a 4% class of the funny category. Before I could feed the data into my models, I had to do some text processing to get it into the correct format. To start, I created a baseline model of logistic regression as on a TF-IDF vectorization, which involves taking the word counts of the words that I'm feeding into the model. The process for the LSTMs is a little bit different. It also involved cleaning the text and tokenizing it. But after tokenization of the words, I created sequences with a max sequence length of 200 per review and padded the sequences in case they were less than 200 words so that each one had the correct length for modeling. So the 4 models that I chose to compare were the logistic regression baseline and 3 architectures of the LSTMs. The first one included 1 layer of 100 memory units. The second one contained 2 layers of 100 memory units each. And the third one contained a bidirectional layer of 50 units looking in opposite directions. The results of my modeling showed that the logistic regression performed the worst in recall and the bidirectional LSTM performed the best. You can see that the precision remained relatively the same amongst the 10% mark. And while this might look low, it's actually doing about 2.5% or 2.5 times better than the baseline at 4% of the funny class. I chose to optimize for recall because that means optimizing for false negatives, which in this use case translates to minimizing the number of funny reviews that we are missing. Take a look at the confusion matrices of the bidirectional LSTM, and the LSTM with 1 layer showed that although the bidirectional LSTM had the highest recall, it actually did not do the best in terms of minimizing the false negatives. The LSTM with 1 layer did better in both maximizing true positives and minimizing false negatives. And so that would probably be the best choice to go with when detecting the funny reviews. So some final thoughts. By fitting the bidirectional LSTM, I was able to confirm that humor is heavily context dependent. And so signals of humor can be given by surrounding words in both directions, not just forward, like with the regular LSTM with 1 layer and with 2 layers. Adding the extra layer also did not significantly seem to improve performance, although it did cost a lot computationally. And to add to the idea that simple might be better, the fact that the logistic regression did very comparably compared to the more complex models also might indicate that in a time crunch, a simple classification might suffice. As for next steps, I want to boost my results using transfer learning using BERT, which is a state-of-the-art NLP model that Google came out with in about 2018, and also create a humor text generator based off the winning model that I come up with. And that's it. Thank you for your time.